We are ready to take off for AI-powered token engineering with Rohan. I had the pleasure to work with Rohan on a proof of concept, how to apply LLMs to token engineering. Super exciting, and I'm super excited to now show you the results. But before we get to that, just make sure to mint your NFT for attending this first ever token engineering full day track at ECC. It's not only a nice souvenir, I mean, you'll be the first who attended this event in the history of token engineering. It's also, yay! It also grants you an additional weight in voting for grants for token engineering public goods. T Commons will run another grant round for token engineering projects in August. And with this NFT, we want to leverage the knowledge in the community. So from the people who are studying T fundamentals, from the people who are interested in topics like this and who can contribute with either talks or with being here, with working with us at the bar camp. Don't forget, 22nd on Saturday in Paris. Pick a flyer. There's a full day of interactive workshops and just networking for the token engineering community. It's free. You can still register, and I hope to see you all there and mint your NFT. All right. Stage is yours, Rohan. Have fun.
Okay. If this doesn't follow me, please let me know. So yeah, hello everyone. Welcome to this talk on AI-powered token engineering. I'm really excited to share my work for the last few months, but before I start my talk, I want to especially thank Token Engineering Academy for championing this field and organizing this amazing track. I've learned so much from Trent, Akim, Roderick, Mark, Gauntlet, Jan, and especially Trent and Jan recently just mentioned that LLMs can be used in the process of token engineering, and it's so cool that I can actually showcase the work that we've done and the agents that we've built to actually aid in the process of token engineering. Okay, we can skip this. So basically, I'm Rohan Mehta. I'm a data scientist. I'm a token engineer. And this project is a proof of concept that has been jointly funded by both the Token Engineering Commons and Token Engineering Academy. I have the pleasure of collaborating with Angela, the founder of TE Academy, and Roderick, our tokenomics advisor. I will be covering the overall goals of this project, discuss the token engineering and modeling process. I'll go through a tiny section of explaining what large language models are and how we can build agents on top of them. I will also demonstrate the basic structure of how LLM agents can be built. But more importantly, I'll actually demo what we've built and how agents can be really used in a real token engineering model. But before we get ahead of ourselves, I'll just give you a brief context of what token engineering is. I'm sure all of you guys know this by now, but token engineering is an emerging discipline focused on the design, validation, and okay, I'll just look here. The design, validation, and optimization of token-based economic systems. Modeling and simulations are a huge, essential part of the token engineering process, playing a pivotal role in understanding, testing, and optimizing the various aspects of the token ecosystems. So they enable us to run what-if scenarios, explore relationships between parameters and metrics that we choose. They provide somewhat like a sandbox environment on which we can run experiments for the ideas that we are stress testing. By leveraging these techniques, we can usually make more informed and data-driven decisions. In a nutshell, I would like to just go through the process of modeling. This is not a linear flow, but, and we've heard this again and again, like everyone's using a different model and different structure of analyzing and building models themselves. But the general structure is that you first represent the real token ecosystem using some kind of assumptions, some kind of metrics and some kind of parameters, through which then you go and justify your assumptions by actually getting real-world data and making sure that the numbers that you're guessing for the system to be is somewhat accurate. Then we change parameters, do A/B testing. We compare the outcomes with each other. We do sensitivity analysis, Monte Carlo runs, and other such runs to then do statistical analysis on top of the results that we get. A lot of these tools, it's interesting to see that they are modular, and this will play a role in what we are building in the future. So very often, even after having built a great model, you can find yourself staring at hundreds of parameters. You have no clue, okay, what to do next, what question to ask the model, what scenarios to test, and also how do I get it done? Because every model comes with a different structure, and now I have to understand what the assumptions were, how did they actually structure the model, how do I change the parameter. All of that is up in the air depending on how the modeler has built it. So our hope, okay, I'll get to it. But what we discovered using LLMs in this process is that it's really useful in managing simulations and drawing conclusions from the simulations that are already built. They're really effective at searching through even and pointing to contextually relevant information from databases. So if you have a huge set of information that you want to go through, it's really effective at searching semantically through what the closest meaning is in all of those documents and fetch that information for you. They're really effective at analyzing data frames and through which we can draw conclusions and eventually make decisions. Our hope is that once we create a structure for agents, it'll also standardize the process of team modeling and simulations because it'll make it so much easier to interact with our token engineering models, giving a language interface to them. I want to highlight that we don't expect LLMs to be able to build models from scratch. Nowhere in the near future we can see that happening because there are too many creative decisions to be made when you're building a model. You have so much context about the market that needs to be put in, and I don't think, even with higher token limits within our natural language models, we'll be able to ever get there. But the general structure that we are following, the wider picture we have in our mind, is that there are 4 sections to this. One are the models of token systems that token engineers build. On the other side, there are AI assistants that provide human language interface to support the simulation process. We have data benchmarked by humans, by actual subject matter experts, which is offered to the AI as a backend memory. And I'll show you how that works. Ultimately, our goal is to use all of these 3 nodes to finally get to something that's verifiable and auditable for our token systems. In order to actually showcase our results, we pinpointed one use case that would be relevant to most users, which is the token sales scenario, or like fundraising via tokens. And this is definitely something every crypto project is dealing with at some point. So I think it was very useful to find a model that Roderick McKinley has built. We used his tokenomics sales calculator, which is a spreadsheet model, converted it to a Python model, and we built agents on top of it. But the general structure is pretty similar. It's like there's allocation charts, there's vesting schedules. There are a couple of things that you have to track, like token price, fund raised, the unlock schedules, and the token allocations of various stakeholders. So very standard, like we've all seen this everywhere in white papers. I'll quickly go through the basic structure of the background before I demo the agents themselves. That let's say you're a startup and you have to decide how much fundraise amounts you need. So a very standard set of questions you would have is like, okay, what's my monthly cash burn? Let's say 115,000. You have to plan for contingency. You have to cover a runway of, let's say, 36 months. And let's say there's some listing costs that you're looking forward to. So when you add all of that up, very simple calculation, you come to a total sum that you need around $5 million. Very simple calculation from your end. This is the money you want. But the investors take a completely different perspective. For investors, they majorly will look at FTV. That's not the only thing, but I mean, we are simplifying for now. FTV is a very important thing that they look at, which depends on the token supply that you decide. Also depends on the token price that you're selling them at, the percentage allocated to them, and all of these are kind of interconnected. And what you realize that there's a multi-dimensional problem. There's no easy like, oh, I can just chain this, or I can just chain that. It's all connected together. And these are the kind of problems where AI agents can support us with parameter optimization after giving them a goal that we want. I have to highlight this since Roderick is here, and he's been talking about this a good deal in his talk too. These are all like human decisions at the end of the day. There's no objective, right, numerical answer to any of this. And it comes down to how humans negotiate, who has the bargaining power, etc. But given certain constraints, we can actually at least ask the model certain questions, and it can guide us through the process of it. I can jump into, I'll have to switch this. Can someone help me? Yeah. So I can jump into my demo now. Also, how many of y'all are like coders? Do you guys understand like, okay, 1, 2, 3. All right, cool, that helps. Yeah.
Now you don't.
Yeah, that's okay. Can someone help me out? Okay, got it. This works? Okay, good, perfect. Okay, so basically we went through filling all the parameters like fundraising goals, token supply, etc., etc. We got to a vesting schedule, something like this. So we are using this as the base model to actually explore agents. And this is basically a coding environment where I can write my question. Imagine this as like your ChatGPT chat box where you can just pretty much ask any question that you want. The agent itself has information about the model that we're using. So you can ask something like, okay, what is my token supply? Not very impressive, but wait, let me just see this. Yeah. So what is my total token supply if we ask this? We'll see that it runs through a set of codes. It's entering a new chain. Some weird stuff is happening in the middle. And it gave a final answer at the end. The total token supply is 180 million, which is what we had fed in. So it's cool, okay, it can access the stuff that we put in. We can also ask, let's say, whatever rest is like, okay, what is our fundraise amount? Give me a second. Yeah, fundraise amount, let's go. Thank you, Copilot. Yeah, and again, same thing. Went through a series of steps. Did some mysterious stuff in the middle here, and got to an answer. And I will showcase exactly what happened in the middle. And this is 5 million, by the way, the same one that we had accounted for. This is very interesting. This is where stuff starts getting interesting. Let's say you're at a stage where you have to now decide what your allocation schedule should be, your allocation amounts should be for different investor groups. And you can, if you don't know, you can just kind of ask, like, what is the average allocation? Second, the allocation in my sector. And it's actually has access to a memory database. So the way it works is it semantically searches through a huge set of vector storage and finds you the correct article or the research that we have curated, picks it out, sends it back to you. Currently, it's hard-coded, so don't overthink it. But basically, if you read this, based on the similarity search on the benchmarking documents, the closest match I found was on page 30 of PDF, whatever. And it was able to pinpoint your answer. So it's very interesting to know that in a normal large language model, the issue is that there's no traceability back to the data. It's very hard to figure out, if you ask a question, where did it learn this information from? But we are not building our own large language model. What we're doing is using OpenAI or any kind of large language model to do a set of tasks, a chain of calls to itself, while giving it tools and memory. And I'll showcase exactly the structure we are using. So what's happening step by step is that we are first asking a question out here, what is the average allocation in my sector? It understood what it needs to do. It needs to figure this out in the benchmark data. It took an action in the real world, accessed our database, ran a similarity search, gave an answer, and then finally gave an answer back to us in a human-readable format, which is something like 26.6% for private sale, 1.1% for public scale. This is the ranges that I found and took an average of it. So we start seeing that it has access to some benchmark data and memory, and it is able to fetch the relevant information based on the question you ask. There's another thing, like it can also give you suggestions about the things to do. So you can ask, like, let's say your private round investors they're like, okay, your fundraising valuation is too high. You need to make it 15% lower. So we can just type it out. My private round. Oh, thank God it remembers this. I'll just percentage. Round is percentage higher than my target. What should I do? Boom. It's able to understand what the question is, and you can see that first it understood that based on the question, what it needs to do is first find out what is FTV connected to. And it figured out that there are total token supply and token price are the two things that change your FTV. Then it figured out that it needs to use an optimizer to reduce the FTV by 15% while keeping these two, like finding the values for these two. And it gave you an answer like, oh, we can either, this is the final answer, reduce token price down to 0.085 or reduce token supply to 153 million to reduce FTV by 15%. Again, forget the actual, what's really happening, and that's cool out here, is that it understood the question, figured out which tools to use within the skill sets that's available to it, chained them together in a way that made sense, and actually gave us an answer in natural language, which is very fascinating here. Another thing we can possibly go into, how much time do I have? Okay, I have time. What's my token supply at, okay, so yeah, you can query the data set that your CAD model has already built. So you can ask questions like, what is my token supply at month 12? Yeah, so something like this, like what is my token supply at month 12 as a percentage of the final token supply? So for this, like what I would do as a data scientist, I would first locate the 12th row, like the month, and then find sum all the tokens on that. Then go to the final row, sum all the tokens, divide this. Let's see how, probably the same, yeah. And it also understood that it needs to remove one of the rows out of the column, which is interesting. That's probably the month row, and we can check the third. Oops, not this one. But yeah, so it's actually doing like straight up data science stuff and answering questions based on what we've asked. Yeah, so the final row was month. And it figured out that it needs to not include that in the circulating supply calculations, figured out what the value was for month 12, observed it, had a thought, okay, what should it do next? Used an action on the Python shell that it has access to, run the pandas command, got the answer 180 million, which was our total token supply, and finally gave us an answer in natural language. So again, what's fascinating is it has access to so many tools which it can use based on what the question is being asked. It can chain these tools together, it can fetch memory and then chain tools on top of the memory. So that's where like the real power of AI, you can start seeing that you're just giving it a goal, like this is what I want you to do. It figures out all the intermediate steps based on the skills we've given it to get to the final answer. I feel like I should show you all how we've done this because it's really fascinating. Let me try. So we followed two major prompt engineering breakthroughs that happened recently. One was the chain of thought reasoning that people figured out, that we can force LLMs to think through the task way more than it normally does. We can force it to have a thought, then take an action, then observe the results, then have a thought and take an action, keep doing this loop again and again. This forces an LLM to have a much deeper understanding of what it should be doing. And the second thing that we did is, I don't know if you all heard of Baby AGI, but they came up with this plan and executor loop, which is what we are following. We built a planner agent. All it does is it knows what information it has access to, the memories, which is here. It knows what skills it has access to, which is like a Python shell or a SQL shell. It has maybe access to a Wikipedia search, so it can fetch information. In our case, it's a database. It knows what it has. All it needs to do is make a plan. If this is the goal, step 1, step 2, step 3, step 4. And then the executor agent has this thought observation loop, which is what we saw here, out here. So it has a thought. I need to find the token supply at month 12 and then compare it to the total token supply. And then it executes every set of tasks one by one. So what we are doing here is not building a language model. What we're doing here is leveraging the already built language models, giving them memory skills, putting them out in the real world, giving them a goal to achieve. And that's why we call them agents. There's an ingestion engine, understands the input, figures out which agent to use, plans the set of tasks, goes through loops of thought, observation, action loops, and gives you an output at the end. What's really cool about this is that, to me, like within data science or like even token engineering, we can isolate the kind of tasks that we generally do, something like sensitivity search, parameter sweeps, A/B testing. We can abstract them away as skill sets and teach an agent how to go about it. Like if I was and that's probably what I'll be working on next now, like is like build a data frame of, this was the question, these are the things I would have done. I would have first done an A/B test, then based on the result, I would have done this, then done that. If we can make an entire data frame of how I would have gone about answering the question, we can dynamically prompt engineer really powerful agents. We can figure out with every model, not even like, in our case, we are using a very simple model, but you can have really complicated models where it's understood the series of steps to take to answer questions the way a data scientist would have. It's still, there are a lot of limitations here. It sometimes makes a lot of mistakes in picking tools, sometimes makes mistakes in actually sending the relevant information to the tool, so it can't run the functions that well. It happens, but to me, it's like as the language models keep getting better, we'll be able to have a higher token limit through which we can solve this issue. And in conclusion, can I share the slide here? Is that? Okay, it's working, good. In conclusion, what I just wanted to say is that this chain of thought reasoning method is super powerful. And Trent and everybody else that spoke about it, like Trent was going from like the bottom up, like using AI to go all the way down to the ground and solving the questions from down below. We are attacking from the top. What we're doing is making these tools easy to use. Because the issue currently is that we have all these amazing tools that have been built, like CAD, Token Spice, but no one's using them. So maybe if we can build these models and give language interface access to everybody, this possibly helps a lot of people use the tools way more, make it more accessible to people. At least the easy stuff can be automated away. And if you want to see how we build these agents, there's a drag and drop method to actually build the chatbots. Meet us at the Barcamp. We are going to showcase how to go through the process of building agents, how to give them memory, skill sets. And this will be super exciting. You can scan the barcode here, and I'll be giving a workshop there. Yeah.
Thank you, Rohan. Yeah. We have time for 1 or 2 questions.
Thank you very much for a great demo. A really great job, guys. One question with this specific prompt about lowering FDV.
Yeah.
So the agent figured out that he needs to either change the total supply or the price, and it was based on the skill tree that you needed in upfront to code.
Yeah.
Okay, this is how it works. So what will be the effort or I don't know, next steps in order to bypass this step of providing some upfront skills? Because we can imagine, right? If, for example, agent would be able to write CAD models or do something with these models, then if we would need to, in upfront, to provide the whole skills tree to learn his, I mean, that would be pretty challenging. So what do you think, how we could bypass this step in order to basically not provide any skills tree and still the agent will be able to deliver the task?
So there are a couple of approaches we can use. First of all, good question. I do think that one way to bypass it is first, so in this case, we had very specific skills that were used to do specific tasks. Not very impressive, honestly. But I think what we can do is abstract away the steps that data scientists generally use to get to an answer and build a data frame of questions. So that's the current idea I have, which is that you can dynamically build few short prompts through which, so it's called few shot learning, which language models are really good at. So we have a data set of all the tasks that I would have done as a data scientist on this model. It fetches that, uses the A/B test sensitivity search based on the question. So that's generally the approach everyone's doing. We were at this hackathon yesterday, Crypto AI hackathon, where at least 2 people were using similar approaches for their problems. So it looks like that's the state-of-the-art practice for now. But honestly, every month, you see a new paper coming up in this field, and something completely fundamentally shifts. We figure out a new way to use these language models in a much more effective way. So that's my current understanding of it. But I do feel like if we abstract away the basic data science tooling, it should be applicable to most models, and we won't have to redo them for every model. Yeah.
Second question, maybe?
Yes.
Yeah.
Thank you. Hi, Malisha here from Streamflow. We help teams with the token vesting, so this is highly relevant for us. First of all, very nice talk and seems very well thought through, and looks like these are the cutting edge tools that you're using. My question is, how can we access these tools and how can we use them as well?
Happy to talk. Seriously, let's catch up because I think there's a lot of value in combining data, aggregation of data, benchmarking, models for running simulations, the AI on top. So there's a lot of potential here.
The whole distribution, the whole flow.
Exactly.
Okay, but these are not publicly available tools.
Not yet, but my idea would be that if we can figure out a standard practice through which token engineering modelers can build API access to their models, maybe we can put a language model shell on top of it where these agents are available. That could be the best way to standardize and make these open source even if it's possible. But there needs to be standardization for the modeling process first. And but yeah, we have to discuss this. Yeah.
Okay, thank you.
Yeah.
All right, we have a short break and then we continue with two discussions actually, how to establish token engineering at your startup. We have now heard about verification tools, verification approaches, design approaches. The big question is how you can make this work at your project, integrate this in a roadmap for a project and get things going. So stick around and we'll see you in a moment.